Hello, everyone. Today we're going to learn how to use FlorDB, a nimble experiment management tool for iterative machine learning. This system was developed at UC Berkeley's Rice Lab to enhance the efficiency of machine learning training and debugging. And I am Rolando Garcia, a PhD student and project lead. First, you want to make sure that FlorDB is installed on your machine. To install it, simply use pip and run pip install FlorDB in your terminal. Now let's get started using with FlorDB. The first thing you want to do is to select a Git repository where you'll be saving your model training code as you iterate and experiment. You can create a new Git repository or select an existing one. In this video, we will be using a sample repository for our demonstration. Here's how you would clone it. Next, you'll want to run the train.py script to train a small linear model, and this will also test your FlorDB installation. You can do this by running the following command. As your model is training, FlorDB will manage checkpoints, logs, command line arguments, code changes, and other experiment metadata on each run. This data is accessible via SQL or Pandas queries. Now that we've started the training process, let's look at how you can view your experiment history. From within the IPython terminal, run these commands. This will give you a nice structured view of your experiment history, showing both metadata and the data that was logged. Now that you know how to run an experiment and view your history, let's explore how to run more experiments and manage hyperparameters. The train.py script we used earlier has been prepared in advance to define and manage 4 different hyperparameters. You can control any of these hyperparameters using Flor's command line interface. For example, to adjust the hidden parameter, you can run Python with the hidden CLI flag set to 75. For more advanced use cases, you can use flor.batch to dispatch a group of executions that can be long running. For instance, to run a batch of jobs with varying hidden and LR parameters, you can do the following. Now that I have submitted the jobs to execute, I will run a Flor server. So I'm calling Flor, telling it to start on CPU, and it's going to start working away on the batch jobs. As the Flor server executes jobs from the batch, we can check the progress using a SQLite command. We're accessing the jobs table, and then we are grouping on done and path to get the count. And we see that we have about 5 executions left to go. Now that the Flor server has finished processing the batch jobs, I can confirm that all 10 batch jobs have finished. The Flor server is waiting for additional work, and so I can move forward. We view the updated pivoted view now with all 12 versions logging and enabling us to compare the loss, epochs, learning rate, and so on. Now that we've covered the basics of FlorDB, let's delve into some more advanced features, starting with the logging API. FlorDB provides a simple but powerful way to log metrics and register tunable hyperparameters during your experiments. To use the logging API, you just need to call flor.log to log metrics and flor.arg to register tunable hyperparameters. Let's take a closer look at this action within our train.py script. We can see that there are the 4 arguments with default values, as well as the loss that is being logged. Then the names you use for the variables, loss, hidden, epochs, with floor.log and floor.arg will become a column or measure in the full pivoted view, making it easy to track and compare across different runs. So make sure you give your logs and arguments descriptive names. And finally, we will demonstrate hindsight logging, which is the main application that motivated the development of FlorDB. So for hindsight logging, we would return to our ML tutorial directory, and we will be opening the train.py script. And so this is hindsight logging. So what this means is, even though we've already executed 12 versions, I might want to come in and insert additional logging statements. So I may want to start logging the device that I'm using. So I want to know whether this model is training on a CPU or a GPU, for example. So I log the device. And I will also want to get to the accuracy. So I've added 2 logging statements. I just want to save my work here. Okay, so I finished adding those 2 logging statements. I will put this terminal away for now and return. So now I'm going to verify that I can see those logging statements that I just added, the device and the accuracy, and that is correct. And so I will commit those new logging statements to the Git record. And so this is within our FlorShadow branch. And so these logging statements will now be available in the future for retrieval. So when someone asks for the device or accuracy logging statement, they can check this version and recover that code. So now, even though we've added the hindsight logging statements, we're going to demonstrate how those logging statements get patched into previous versions. It's like rewinding time and backfilled. So before I do that, if I were to come in here and check, so I'm going to introduce that line. Let's take a look at what the pivoted table contains. So the pivoted view is going to be everything that we've been logging so far in this tutorial. And we see that there's loss, epochs, LR, batch hidden. And so there's no device or accuracy that is being logged, you can see. So I will close this out for now and continue with the replay. So when I run replay, Flor is going to do a static analysis of the source code and determine the logging level of the logging statement. So how much work will Flor have to do? What kind of checkpoints will it have to access? In this case, data preparation is correct, as well as in the accuracy, because they're both at the same level. Neither one of them requires Flor to step into the main training loop, which would otherwise mean outer loop or inner loop replay levels. So given that information, Flor estimates 12 versions need to be accessed, and each version is going to take some time depending on the seconds preparation, as well as the amount of time that it's going to take in evaluation. And so Flor is going to make an estimate of replay, and then we can accept, confirm that, yes, we wish to register those replay jobs. And then earlier, we had defined a Flor worker that is still spinning, and so it's completing that job. It's stepping in time by time and doing a fast pass because of the data replay level. And we are seeing that it's collecting information about the accuracy that it had not logged on the first pass, as well as information on the device. So now Flor has finished. We see that this was much faster than on the first pass when we did the Flor batch. So I will now put this away, and I can scroll back down, confirm that the replay jobs, this is how I would have monitored it if I had hundreds of replay jobs, for example, and I wanted to track their progress. So they have finished executing, and then I should check and find, in fact, that now my pivot table does include information on the device and accuracy. And even though I added those logging statements late, I have that information now for analysis. Thank you so much, and please don't hesitate to reach out with any questions or comments. Thanks so much, and have a great day.